Hey guys, tonight we slip into the velvet dark of the cosmos, that quiet hour when the air seems heavier and your room hums faintly like a spaceship cabin. You imagine yourself floating, tethered only by the thought that somewhere out there, the universe hides secret passageways. Wormholes, they call them. Real gateways in space. Tunnels that might cut across billions of light years like sneaky shortcuts through the back alleys of creation. You picture two distant stars, separated by gulfs of black void, suddenly stitched together by an invisible corridor, as though space itself had folded like origami. Sounds thrilling, right? Well, you probably won't survive this, but let's not get ahead of ourselves. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your location and the time in the comments. I want to know if you're listening under the blazing midday sun or drifting towards sleep with only the sound of night insects outside your window. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge mentally across the fabric of space-time, and at first glance, it feels like a simple canvas stretched taut. But the more you stare, the more you notice it's not flat at all. It's rumpled, like a blanket kicked by a restless sleeper. Every planet, star, or black hole presses down on that sheet, warping the geometry. That's Einstein's general relativity for you. Mass tells space how to curve, and curved space tells matter how to move. An obvious truth. Gravity isn't pulling you down in some mystical way. It's nudging you along a dent in the mattress of existence. Now here's the quirky tidbit. If you were to shrink down to the size of an ant on that cosmic blanket, the dents would seem like deep valleys. And if you were really tired of climbing out of one valley to get to another, you might think, why not poke a hole straight through the blanket instead? That's the essence of the wormhole idea, a tunnel punched into space-time, connecting two valleys that might otherwise take forever to traverse. But your imagination isn't the first to wander here. Long before Einstein, storytellers played with portals. Norse myths speak of Yggdrasil, a cosmic ash tree bridging realms. Folktales whisper of fairy mounds with hidden doors. The dream of stepping sideways into another place, skipping the long road, has been woven into human thought for millennia. You realize that wormholes are just science's modern skin over a very ancient yearning. You lean closer to this warped canvas of space-time, picturing the Earth bending it ever so slightly. A marble circling a bowling ball, that classic classroom demo. But then you scale up, way up, until galaxies themselves are like coins pressing into the sheet. Between those vast dimples, the distance is monstrous. Even if you traveled at light speed, it would take 2 million years to cross from the Milky Way to Andromeda. Your starship snacks would definitely expire before you got there. That's why the thought of shortcuts is so tantalizing. A wormhole promises to cheat the rules. Fold the paper, make the two dots touch, draw a tunnel between them, and suddenly, what was impossibly far becomes a mere step away. It's like skipping the line at a cosmic amusement park, though with a much higher chance of being spaghettified. You remind yourself of the scholarly debates still swirling. Physicists argue whether wormholes are even allowed by the equations of relativity. Some solutions hint at them, others collapse as soon as you tug at the math. It's as though the universe teases the idea, dangling it just close enough to make you wonder, but never close enough to confirm. Could wormholes exist naturally, or are they strictly forbidden by the cosmic rulebook? Nobody knows for sure. Historians of science even argue whether Einstein himself believed these structures were real possibilities or just mathematical curiosities. But you lean into the wonder. You picture yourself at the mouth of such a tunnel. The stars ahead stretch and twist, light bending in ways that feel both beautiful and wrong. A shiver runs down your spine, not just from the imagined danger, but from the awe of standing at the threshold of a phenomenon that might bridge the unbridgeable. And of course, because you're you pause to wonder what snacks to bring. A wormhole trip probably won't have many gas stations along the way. Then comes the playful jab of reality. Even if a wormhole existed, it wouldn't be some convenient, glowing circle like in sci-fi movies. It might look more like a sphere of distorted stars, a bubble in space that tricks your eyes. Step in, and who knows whether you'll pop out somewhere in the galaxy, or somewhere in the Jurassic period. Not the best vacation planning tool. Yet the idea refuses to die. You think of explorers on Earth staring at maps, desperate for new trade routes. They dreamed of canals through continents, passages through ice, anything to make the world smaller. Wormholes are just our cosmic canals, the dreamed-up Panama passages of the universe. Maybe impossible, but too tempting to ignore. As the night deepens, you feel your thoughts smoothing into the gentle rhythm of speculation. The room's shadows lengthen. The hum of your fan becomes the background soundtrack to interstellar wandering. You're not just imagining tunnels in space. You're feeling them, corridors carved into your own drowsy mind. Somewhere, between the obvious truth of gravity's curves, the quirky tidbit of ant-level tunnels, and the scholarly debates that rage in physics halls, the dream of wormholes nestles. Not proven, not disproven, just waiting, like a half-remembered secret. And here you are, perched on the edge of that dream, ready to drift deeper. You drift forward, still clutching the thread of curiosity that first tugged you into this starlit thought experiment. And now you're staring straight at Einstein's warped canvas. Imagine the cosmos not as an endless emptiness, but as a flexible arena, pliant, elastic, able to ripple and bend. That's what general relativity insists on. And whether you like it or not, you're caught inside it, sloshing around like a pea in a rubber sheet. An obvious truth here. Space and time aren't two separate boxes. They're stitched into one seamless quilt called space-time, and it curves around anything with mass or energy. You pause to admire the elegance of it. A planet loops around a star not because the star exerts some mysterious pull, but because the star's bulk has curved space-time itself. You're just rolling along the groove carved into the universe. Like marbles circling a depression in that rubber sheet, everything dances along in visible troughs. A sleepy image, sure, but one with staggering consequences. Now, here's your quirky tidbit. Einstein apparently wasn't a big fan of wormholes themselves, but his math didn't care. The equations spilled them out anyway, like an overeager baker tossing in too much yeast and watching the dough bubble over the bowl. When Carl Schwarzschild sent Einstein his solution in 1916, essentially describing what we now call a black hole, embedded within that same math was the hint of strange connections, tunnels where the geometry bent back on itself. Einstein shrugged, probably more interested in the elegance of the equations than in cosmic shortcuts. You wander deeper into the analogy. Think of space-time as a trampoline, with heavy bowling balls, stars, sinking deep hollows into the fabric. Drop a smaller marble near the edge, and it spirals inward, not because of any magical tether, but because the path of least resistance is curved. That's general relativity in action, all tied neatly into a truth your body confirms every day. You're not pinned to Earth by invisible strings. You're sliding along the dimple our planet has made in the universe's mattress. But relativity has a mischievous side. It doesn't just say space-time bends. It says it can twist, flare, and maybe even fold into loops. Some scholars argue that wormholes are simply what happens when the math gets a little too wild, pushing beyond what reality allows. Others argue that reality is often stranger than our skepticism permits. Historians still debate whether Einstein and his collaborator Nathan Rosen were trying to open the door to wormholes or close it when they wrote their famous paper in 1935. Let's slip into a sensory image. You're walking across an endless desert at night. The stars overhead shimmer in thin slices, and every dune is another light year. The trek would take forever, but suddenly, the sand ripples beneath your feet and folds. The horizon slides closer. You don't walk the distance. You let geometry do the work. That's the seduction of wormholes hidden inside Einstein's warped canvas. The possibility that space itself can fold to your advantage. Of course, the universe is rude enough to make this theoretical. No evidence, no observed portals, just the math whispering, maybe. And you, stretched out in your quiet room, ride that maybe like a hammock strung between possibilities. It's both exhilarating and frustrating, like knowing there's a secret room in your house, but never finding the door. You chuckle softly, thinking of how pop culture has cheerfully ignored the headaches. Science fiction just draws the wormhole as a glowing donut or a shimmering gate and lets spaceships sail through with the ease of opening a refrigerator. Real physics, by contrast, mutters about singularities, negative energy, and catastrophic collapse. The truth is that general relativity permits the mathematics of wormholes, but quantum mechanics rolls its eyes and says, try again. You're left in the crossfire of two brilliant but bickering theories, both of which run your universe but refuse to get along at family dinners. Still, it's worth noticing how wormholes inspire a sense of cosmic symmetry. If black holes are the ultimate traps, mass collapsed so tight that nothing escapes, then wormholes feel like they're cheeky siblings, offering not prison but escape. If one side devours everything, perhaps another side could spit you out elsewhere. It's the universe as prankster. You drop into doom and might pop out into opportunity. Of course, might does a lot of heavy lifting in that sentence. And here you are, watching the curved fabric ripple, wondering what it would take to press your finger into it just a bit harder, to poke through and see another universe blinking back. That's the dream Einstein's canvas leaves dangling before you. It's not a promise, more like a dare. You imagine yourself carrying a little chalk, drawing arrows on the warped sheet like some cosmic teacher scribbling diagrams. Over here, the sun bends space-time into a cradle. Over there, a black hole plunges it into a bottomless funnel. And somewhere, maybe hidden behind the lines, is a connection between two funnels. You picture yourself circling it, suspicious yet hopeful, like a cat staring at a half-open door. And that, really, is the spirit of this section. The obvious truth: space and time are not rigid. They bend, and you're caught inside their curves whether you notice or not. The quirky tidbit: Einstein's math practically coughed up wormholes like an uninvited guest. The scholarly debate: historians and physicists still can't agree if these solutions point to real cosmic corridors or just mirages and equations. So, you lean back, let the fan hum steady, and let the curved canvas stretch out in your mind. No extra props are needed, just the thought that the universe itself might be a trickster, hiding secret hallways behind the gentle bend of the night sky. You float onward in this sleepy voyage, still balanced on the curved canvas you just traced, and now your thoughts turn to the idea of shortcuts across infinity. Infinity, of course, is not something you can truly picture. It's more of a nagging awareness that no matter how far you go, there's always farther. Traveling across the galaxy at light speed would be like walking across continents barefoot. Technically possible if you're immortal and stubborn, but otherwise hopeless. An obvious truth settles in. The distances out there are absurdly, ridiculously, impossibly large. So, you play with the paper folding trick. Imagine holding a sheet in your hands. One corner marked Earth, another marked some cool exoplanet with beaches and Wi-Fi. If you drag your finger from Earth to that distant corner across the flat page, the journey is long. But if you fold the sheet so the 2 points touch, suddenly, the trip is no trip at all. A wormhole is just that, a fold-and-tunnel cheat sheet for space-time. Here comes a quirky tidbit. Physicists sometimes call this the Alice through the looking-glass move. Step through the mirror, and you're instantly somewhere else. And because you're in a sleepy mood, you can't help but picture Lewis Carroll's Cheshire Cat smirking at you from the other side of a wormhole, tail flicking as though he knows you'll never get this shortcut to actually work. But the metaphor is powerful because it feeds the oldest human itch: impatience. Nobody wants to slog. You complain about waiting in line at the grocery store, so why would you ever tolerate a 2-billion-year starship commute? A shortcut across infinity feels less like a luxury and more like survival. Scholars still argue whether these hypothetical tunnels could actually provide such a bridge, or whether they'd collapse into chaos the moment you set foot inside. Some papers claim the math holds. Others fold their arms and declare that the fabric rips under stress. The debate is as endless as the distances themselves. You stretch the thought further. If wormholes exist, they wouldn't just be shortcuts in space, but also in time. Fold the fabric cleverly enough, and maybe you step not just to another place, but another one. You could peek ahead or tumble backward, though whether you'd like what you find is another story. There's comfort in the monotony of straight time, even if it means aging 1 second at a time in your small corner of Earth. Picture it vividly. You're standing at the edge of such a shortcut, stars twisting into a luminous whirlpool before you. The silence presses close. The air in your lungs feels borrowed. Do you step through? Or do you hesitate, remembering that the math has never promised stability? Most versions of wormholes slam shut the moment matter enters, like a door snapping on your fingers. Still, you can't help savoring the temptation. Imagine explorers setting out not with rockets, but with coordinates, carrying maps of wormhole mouths instead of fuel tanks. Whole civilizations could spring up along these corridors, like pit stops on a galactic highway. You almost hear the sleepy traffic report. Expect heavy congestion at Wormhole Exit 7. Please allow extra time if you're heading to Alpha Centauri. The truth is both thrilling and deflating. Nobody's found a single shred of evidence for these corridors. No strange gravitational lensing that would betray one. No unexplained radiation bursts that whisper, "Portal here." It's all mathematics and longing. But mathematics has surprised us before. Einstein's equations predicted gravitational waves a century before we finally felt them ripple past in 2015. Maybe wormholes are the next cosmic prediction waiting for evidence. Your fan hums, your eyelids droop, and the folded paper image grows softer. You know, deep down, that the universe rarely gives away cheats. And yet you linger on this fantasy, because it scratches the same itch that once made humans cross oceans, climb mountains, and send probes into the void. Infinity is daunting, but the thought of a hidden door, a folded corner, makes it feel just manageable enough to dream. You smirk to yourself, imagining putting this shortcut into Google Maps. Fastest route to Andromeda. 2 million years, avoid traffic. Or take wormhole option, ETA, 30 seconds. You'd probably still be late. And so you let the image linger. A folded cosmos, your path trimmed from forever to now. It's not proven, it's not denied. It's just waiting in the chalk lines of relativity, daring you to dream that infinity can be crossed in a single step. You sink deeper into the folds of imagination, and now your attention shifts to the early whispers of dark portals lurking in the math, Schwarzschild solutions. Back in 1916, Carl Schwarzschild, serving on the front lines of World War I and sick with a terminal illness, somehow managed to work out the very first exact solution to Einstein's new field equations. He handed the world a window into black holes, though at the time nobody called them that. An obvious truth. Black holes are natural consequences of relativity, places where space-time caves in on itself, where escape becomes impossible once you cross a certain invisible threshold, the event horizon. But tucked inside Schwarzschild's equations was something more curious, something like a doorway. It hinted at regions beyond that horizon, at strange bridges where one side of the solution seemed to connect to another. The math painted a picture of a throat, a passage linking two universes, or maybe two separate regions of the same universe. It sounded suspiciously like what we'd later call a wormhole. Here's your quirky tidbit. In those days, physicists didn't really believe black holes existed, let alone wormhole-like passages. The term black hole itself wouldn't appear until the 1960s. For decades, people thought these bizarre objects were just math accidents, like a doodle in the corner of Einstein's notebook that got out of hand. Schwarzschild himself probably didn't imagine spaceships cruising through his solutions. He was just solving equations in the mud of wartime, leaving us a cosmic riddle wrapped in chalk dust. Now picture it. You approach such a Schwarzschild portal. From a distance, it looks like any black hole, black, hungry, haloed by distorted starlight. Step closer, and the edges stretch into infinity. The pull grows irresistible. Theories say that instead of simply crushing you, this hole might open into another region entirely. But that's where relativity plays its cruel trick. For the throat connecting the two sides, the so-called Einstein-Rosen bridge, closes too quickly. It's not a stable highway, it's a cosmic mirage. Historians still argue whether this early glimpse should even count as a wormhole. Some say yes, because the geometry matches the idea of a tunnel. Others say no, because it collapses instantly, sealing before any traveler could dream of passing through. You stand there, suspended in the debate, feeling both cheated and intrigued. Your senses fill with the imagined environment. The sky near a black hole isn't just dark, it's warped. Stars smear into arcs around the rim. Light bent so sharply it looks like the heavens have been stretched through funhouse mirrors. The silence is absolute. No fan hum now, just the pounding of your own heartbeat as you wonder if a step forward means annihilation or transcendence. But then you remember the reality check. Schwarzschild's dark portals weren't meant to be traversed. They're tantalizing shapes in the math, throats that pinch shut faster than light can move. The cruel universe, it seems, teases you with shortcuts and then slams the door. Still, you smirk at the thought of physicists a century ago, staring at these equations with furrowed brows, probably muttering, "Well, that can't be real." And yet, slowly, grudgingly, they came to accept black holes as genuine. Maybe wormholes will follow the same path. Maybe today's doodles are tomorrow's discoveries. And here you linger. The obvious truth that black holes exist as collapsed stars and space-time pits. The quirky tidbit that Schwarzschild wrote down this cosmic riddle while dying in the trenches, and the scholarly debate whether these early bridges deserve to be called wormholes at all. So you hover there, on the lip of Schwarzschild's dark portal, suspended between doom and possibility, staring into a throat that opens only in theory, whispering promises it will never keep. You linger on the rim of Schwarzschild's dark abyss, and then you tiptoe forward into the next idea, the first real christening of these tunnels, the Einstein-Rosen bridges. In 1935, Einstein and his colleague Nathan Rosen took the math more seriously than anyone before. They noticed that the solutions to general relativity seemed to allow a curious joining of two regions of spacetime, like twin sheets glued together at a narrow throat. They imagined this throat as a kind of bridge, and so the Einstein-Rosen bridge was born. An obvious truth here. This wasn't science fiction. This was Einstein himself, the poster child of physics, laying equations that looked suspiciously like interstellar shortcuts. Picture the scene. Two immense funnels facing each other, connected by a tunnel that's thinner than a hair in the cosmic fabric. It's elegant, symmetrical, mathematically neat. You stand at the edge of one funnel and gaze down into the narrowing throat, thinking that maybe, just maybe, you could slip through and emerge on the other side. Now for your quirky tidbit. In their original paper, Einstein and Rosen weren't daydreaming about spaceships. They were more concerned with stitching together two solutions in relativity to avoid pesky singularities. They wanted smoothness, not adventure. If they'd known how many sci-fi writers would seize on their bridge, they might have raised an eyebrow or two. The irony is delicious. The granddaddy of cosmic portals wasn't designed as a passage for travelers at all, but as a mathematical band-aid. Still, the idea stuck. You can't help yourself. You imagine standing in a spaceship, engines humming, ready to dive into the throat of an Einstein-Rosen bridge. The edges glow faintly with distorted starlight, the tunnel stretching out like a cathedral corridor into infinity. But here comes relativity's cruel twist again. These bridges are fleeting. The math says they collapse the moment matter, or you, tries to enter. It's as though the door exists only as long as nobody touches it, like a soap bubble trembling on the edge of bursting. And so the scholarly debate continues. Some physicists argue that Einstein-Rosen bridges are nothing more than idealized constructs, unstable figments of equations, doomed to implode. Others insist that with the right conditions, perhaps some exotic form of matter to hold the throat open, they could remain stable. The disagreement is like an endless tennis match across decades, volleys of papers bouncing back and forth, each claiming the bridge either lives or dies. You imagine watching that tennis match while perched in the bridge itself. One physicist shouts, "It's collapsing," and you see the tunnel walls shudder. Another cries, "It can be stabilized," and you see them reinforce with glowing beams of negative energy. The bridge flickers, both open and closed, alive and dead, Schrödinger's shortcut. The sensory weight of it settles on you. The air in the tunnel is absent, yet your lungs feel tight, as if holding a breath that belongs to another universe. The silence deepens until your own heartbeat is the only percussion. You take one cautious step, but the floor beneath you isn't solid. It's the geometry of space-time itself, curved and stretched, barely tolerating your presence. It's tempting, isn't it, to dream that Einstein himself handed you the keys to a cosmic back door. But reality insists on keeping the lock fastened. The Einstein-Rosen bridge, for all its glamour, seems to be more like a mathematical daydream than a practical road. And yet you smirk again, thinking of how often this happens in science. Ideas that begin as abstract doodles sometimes turn out to be more real than we ever imagined, like black holes, once dismissed as impossible. Who's to say wormholes won't someday make the same leap from chalkboard to cosmos? So here you linger, at the fragile throat of Einstein's bridge, suspended between collapse and curiosity, staring into the passage that dares you to believe. The obvious truth is that Einstein-Rosen bridges emerge naturally from relativity's math. The quirky tidbit is that Einstein and Rosen only wanted a patch for singularities, not stargates. The scholarly debate is whether these throats can ever be stabilized, or whether they're doomed to die before anyone can take a step. And with that thought, you let yourself drift further down the corridor, half dreaming, half waiting, following the faint shimmer of a doorway that flickers but never quite stays. You keep drifting, still carried by the shimmer of Einstein-Rosen bridges, and now your mind latches onto the idea that maybe, just maybe, you could keep such a tunnel open if you had the right scaffolding. And here's where the universe demands a peculiar payment: exotic matter. Not exotic like chocolate-covered pickles at a state fair, but exotic in the strict sense. Matter with properties that don't exist in the everyday world. An obvious truth. Normal matter, the kind making up your body, your chair, and your midnight snack, cannot hold a wormhole throat open. Gravity would crush it shut instantly. Something stranger is required. You picture yourself standing at the mouth of a trembling wormhole, its throat quivering like gelatin. Without support, it will collapse in on itself faster than you can blink. But then, in your thought experiment, you wheel in barrels of exotic matter, glowing faintly like captured moonlight. Unlike ordinary stuff, this matter has negative energy density. It pushes outward instead of pulling inward. Pour it into the walls of the tunnel, and suddenly, the throat stabilizes. The geometry firms up. The bridge stays open. Now here's the quirky tidbit. Negative energy isn't just science fiction hand-waving. Quantum physics really does allow it in tiny, fleeting amounts. The Casimir effect, discovered in 1948, shows that two metal plates placed extremely close together experience a strange attractive force because the quantum vacuum between them has less energy than the surrounding space. It's like the plates are squeezing the quantum froth, creating a pocket of negative energy. In principle, this same quirk could be scaled up to prop open a wormhole. In practice, well, good luck building cosmic bridges with lab equipment designed for nanoscopic measurements. Historians and physicists still argue whether exotic matter is physically possible in the quantities needed. Some suggest it violates other laws, like the energy conditions of relativity. Others insist those conditions are more like guidelines than rules. The debate plays out in conference halls, papers tossed around like philosophical footballs, while you sit back and wonder if anyone has considered simply bribing the universe with cookies. The sensory imagery pulls you further in. Imagine the walls of the wormhole glowing with threads of negative energy, shimmering like spider silk in moonlight. The air tastes metallic, your tongue prickling as though it knows this energy isn't meant for human bodies. Yet it holds. The tunnel doesn't collapse. For the first time, you can imagine stepping through without the walls crushing you into a cosmic pancake. But then comes the second reality check. Exotic matter, if it exists in stable quantities, would be absurdly dangerous. Negative energy could, in principle, cancel out normal mass, levitate objects, or even destabilize space-time itself. It's the kind of ingredient that belongs in the handle with extreme caution section of the cosmic pantry. If your neighbors thought you were weird for composting banana peels, imagine their faces when you roll a glowing barrel of exotic matter into your garage. Still, the dream persists. Because wormholes without exotic matter are soap bubbles. With exotic matter, they might be gates. You lean into that contradiction, savoring it like a paradox-flavored candy. The obvious truth: stable wormholes demand something beyond ordinary matter. The quirky tidbit: the Casimir effect already hints that the universe can produce negative energy, at least in small doses. And the scholarly debate: whether scaling this up is genius waiting to happen, or pure fantasy with equations as props. As you let this imagery unfurl, the fan hum mixes with your own thoughts until the exotic matter barrels feel almost tangible, glowing softly in the dim corner of your room. Maybe they're not real, but for tonight, they're enough to keep your wormhole open, just long enough for you to dream of stepping through. You stand inside that softly glowing tunnel, exotic matter woven into the walls like threads of neon ivy, and yet you feel the tremors underfoot. Even with your precious negative energy propping it open, The wormhole shudders as though it knows you don't belong here. Stability. That's the monster under the bed tonight. An obvious truth. Wormholes are not naturally stable. Every equation screams collapse the moment anything, light, radiation, let alone a spaceship, tries to pass through. You imagine it like holding open a soggy cardboard tube. The instant you try to push a marble through, the tunnel folds, crumples, and shuts. No shortcuts today. Unless exotic matter is there in exactly the right amount, at exactly the right configuration, the geometry collapses like a bad soufflé. You can almost hear space-time huffing. Nice try. Here's your quirky tidbit. Kip Thorne, the Nobel-winning physicist who advised the movie Interstellar, once wrote an actual paper describing how advanced civilizations could, in theory, stabilize a traversable wormhole. He and his colleagues even specified the tidal forces needed to keep a human alive while traveling through. Hollywood didn't just pull its glowing circle of stars out of thin air, it leaned on real equations. Of course, those equations still demand exotic matter, and lots of it. So you're left wishing your grocery list could casually include 1 metric ton of negative energy, please. But even if you had your impossible fuel, the stability problem goes deeper. Wormholes might radiate energy in wild, unpredictable bursts. They could shake themselves apart the moment a photon dares to enter. Some physicists describe it like feedback in a microphone. Once light starts bouncing around the tunnel, it amplifies uncontrollably until the structure tears apart. You picture yourself inside such a throat, the walls vibrating, the geometry screaming like an overworked amplifier at a garage band concert. Not exactly a peaceful commute. Historians and theorists still argue whether stabilization is possible at all. Some claim the energy requirements are so extreme that no civilization, no matter how advanced, could ever muster the resources. Others counter that physics has surprised us before, and what seems impossible in one century might become child's play in another. The debate drifts on, unresolved, as though the wormhole itself is shrugging, refusing to reveal whether it can be tamed. The sensory image sharpens. You're inside a wormhole that's beginning to buckle. The light distorts, stars outside stretching into jagged arcs. The walls pulse, narrowing and widening like the throat of a living creature trying not to gag. Your stomach knots as though it knows the tunnel's about to snap shut. The silence around you deepens into a pressure, and for a second you're convinced you can hear the collapse, the hiss of space-time folding back on itself. And then it's gone. You're back in your quiet room, fan humming, no cosmic implosion. But the unease lingers. You realize that wormholes, at least in theory, are like those shimmering soap bubbles you blew as a kid. Beautiful, tantalizing, but doomed to burst if you poke them. You might dream of stepping through, but reality grins and slaps your hand away. Yet you smile anyway. Because even if they collapse, wormholes refuse to leave your imagination. They haunt equations, sneak into movies, and linger in late-night thoughts. And you know deep down that humanity thrives on chasing unstable dreams. The obvious truth. Wormholes collapse under even the slightest disturbance. The quirky tidbit. Kip Thorne himself sketched blueprints for stabilizing one. If only we had negative energy to spare. The scholarly debate. Whether stabilization is possible in principle, or whether the universe has locked that door for good. So you let the tunnel close, the exotic scaffolding crumbling away, and you lean back into the darkness with a smirk. Because even if you can't walk through tonight, you've still wandered far enough to keep the dream alive. You sit with the collapse still echoing in your imagination, and your thoughts spiral naturally toward another whisper of instability, Hawking's radiation. That eerie phenomenon, predicted in the 1970s by Stephen Hawking, suggests that black holes aren't the eternal traps we once thought. They leak, not a gushing torrent, but a faint trickle of energy seeping out, slowly evaporating the very giants that were supposed to last forever. An obvious truth. Nothing in the universe, not even black holes, can escape the laws of thermodynamics. Everything runs down eventually, even the most terrifying engines of gravity. Now picture how that ties to wormholes. If black holes themselves slowly dissolve like cosmic ice cubes in the sun, what hope do their wormhole cousins have of lasting long enough to ferry you across the stars? You imagine standing before a wormhole throat, only to feel its edges flicker and crumble under the weight of radiation, as though the geometry itself were burning away in faint, invisible sparks. Here's your quirky tidbit. Hawking's idea of black holes evaporating was initially met with skepticism. The image of something that devoured everything, including light, slowly leaking particles like a nervous kettle felt absurd. Yet over decades, physicists grew to accept it, even though we've never directly observed a black hole evaporating. They're simply too massive, their lifespans stretching longer than the current age of the universe. But if tiny black holes exist, perhaps created in the Big Bang, they could already be fizzling out, popping like firecrackers in the dark. Imagine one of those linked to a wormhole throat, its passageway vanishing in a flash before you could even lace your cosmic hiking boots. Physicists still debate whether Hawking radiation spells the end for wormholes entirely. Some argue that evaporation destabilizes the tunnel, reducing it to nothing more than a mathematical mirage. Others counter that perhaps exotic matter, or some quantum loophole, could shield it, preserving the corridor. The disagreement lingers like an unresolved chord, humming at the edge of theory. The sensory imagery sharpens. You're standing near a black hole, its horizon trembling faintly, as though heat is rising from invisible flames. You can't see the radiation, it's too subtle, but your skin prickles as though you're standing near a furnace that exists only in math. You imagine the wormhole's throat nearby, quivering under the same process, evaporating not in a roar, but in a patient hiss. The tunnel shortens, narrows, and then winks out, leaving you stranded in ordinary space-time. You smirk at the absurdity of it. Even when physics tries to hand you a shortcut, thermodynamics steps in like the universe's grumpy security guard. Move along, no free rides here. It's almost funny, the way the cosmos insists on balancing its books, even when it ruins your midnight fantasies of interstellar road trips. And yet the very fragility of these structures makes them more alluring. If wormholes were common, if they hung in the sky like neon exit signs, maybe they'd lose their charm. Instead, their constant collapse, their evaporating throats, their refusal to cooperate, they make you want them more. The dream survives because the reality refuses to. So here you are, in your dimly lit room, lulled by the fan hum, pondering tunnels that fizzle away like cosmic sparklers. The obvious truth: Hawking radiation means nothing lasts forever, not even black holes. The quirky tidbit: tiny black holes from the Big Bang could already be exploding out there like forgotten fireworks. The scholarly debate: whether this evaporation kills wormholes completely, or whether clever physics might yet keep them alive. And with that thought, you let the image soften, a wormhole throat glowing faintly, shrinking, flickering, until only starlight remains. A door that closes before it was ever really open. You let the last sparks of evaporation fade and keep zooming inward, past atoms, past nuclei, past quarks, and the math that names them, until rulers and clocks start shrugging at your questions. At the Planck length, about 1.6 times 10 superscript 3 meters, and the Planck time, about 5.4 times 10 seconds, space-time refuses to sit still. You picture it as the surface of a midnight ocean seen nose to water, not flat, not calm, but jittery, frothing, fizzing with tiny ripples that appear and vanish before your thoughts can catch up. John Wheeler gave this nervous picture its name, quantum foam. You float above it, listening to the hush between your own breaths and the soft purr of your fan, imagining that somewhere under the universe's glossy surface the floorboards creak and the grain of reality lifts. You tread carefully because the rules here are twitchy. The uncertainty principle lets energy borrow against time's ledger, popping in and out of existence so quickly the loan never comes due. Little fluctuations rise like coin-sized bubbles and collapse again before you can blink. Vacuum is not empty. It's a restless bookkeeping of possibilities, constantly trying on shapes the way clouds try on animals. That obvious truth lands with a soft thud. Even nothing is noisy. You feel it as a faint prickle on your skin, as if the air of your room were cross-hatched with silent fireworks too small to see, each spark rehearsing a particle's entrance and then bowing off stage. Wheeler nudges your imagination one notch wilder. If fields can fluctuate, maybe geometry can too. Topology, the very way space is stitched together, might flicker. Tiny tunnels could blink into being and collapse again. Apertures no bigger than the Planck length, wormholes born and erased before a photon can say hello. You picture little throats puckering open and shut like sea anemones in fast motion. It's cute until you remember your earlier stability nightmares. Here the tunnels don't merely collapse when touched. They collapse because touch doesn't last long enough to matter. You are watching doors that open onto other doors and then forget they ever existed. Quirky tidbit time. Wheeler also loved the phrase, it from bit, the cheeky claim that physical things, the it, might ultimately arise from binary information, the bit. Down here in the foam, the slogan feels strangely at home. You sense space-time flickering like a computer that never quite finishes booting. Raw yes/no decisions weaving geometry the way your fan steady or weaves the room's background hush. If reality is a conversation, the Planck scale is where whispers turn into syllables, where the alphabet of being is punched out one uncertain character at a time. Of course, you can't actually see this froth. Any microscope sharp enough to resolve 10 superscript 3 meters would need such stupendous energy that the region would crumple into a black hole and swallow the experiment whole. You ask to borrow a Planck-scale telescope, and the universe replies by eating your lab, a polite no with teeth. Another obvious truth taps your shoulder. Our technology, and likely the laws themselves, bar the door to direct observation. So you make do with metaphors and equations, with thought experiments that feel like holding a conch shell to your ear and insisting the ocean really is inside. Still, the models tease. Some theorists play with the idea that entanglement, the spooky correlation between far-flung particles, might literally be geometry in disguise. The motto ER equals EPR whispers that every entangled pair could be connected by a non-traversable micro-wormhole, an Einstein-Rosen bridge secretly encoded in an Einstein-Podolsky-Rosen EPR entanglement. You grin despite yourself, romance rebranded as topology. Are your electrons holding hands through tiny tunnels? Maybe. But those bridges, if they exist, are strictly look-don't-touch. You can't send messages faster than light through them, and a traveler would find only mathematics where a road should be. Cute theory, lousy commute. Meanwhile, other routes to quantum gravity give the foam different costumes. In loop quantum gravity, geometry may come in discrete chunks, with areas and volumes built from spin networks, little combinatorial webs that click together like Lego. There the foam looks more like a tapestry of quantized threads than sea spray, a lattice of possible angles that jitter and trade places. In string theory, the actors aren't points, but vibrating strings and brains, and space-time itself can emerge from patterns of entanglement on a boundary. Holography doing party tricks with the lights, projecting a three-dimensional room from a two-dimensional script. Different languages, same rumor. Beneath the smooth curve of Einstein's canvas, something granular murmurs. Then there's the audacious path integral view, where you sum over every possible history of the universe, including outrageous ones where space-time sprouts handles and tunnels and baby universes bud off like soap bubbles. You imagine one of those tiny buds surviving, inflating into a separate cosmos that drifts forever beyond reach. If you've ever lost a sock in the dryer, you briefly, unscientifically, blame a micro-wormhole and feel better. At least the sock arrives pre-warmed to its new universe. That's your second joke of the evening. And yes, you're keeping score. What would it feel like to shrink to this scale? You steady your breath and pretend you can. The floor heaves with jitters, distances blur, before and after smear into maybe. Directions lose their meaning the way dreams forget street names. You reach for a tunnel wall and touch possibility instead of brick. The taste in the air is cold metal and static, but your mind warms to the strangeness. You've left the realm of smooth curves and entered the land of restless stitches, the place where geometry is sewn and unsewn faster than you can name it. You are not walking through space so much as surfing the grammar of existence. Yet the foam is not generous to dreamers. Micro-wormholes, if they exist, would be as fleeting as hiccups and twice as rude. You couldn't ride one, couldn't pass a proton, couldn't push a mote of dust. They're not doors. They're the suggestion of doors, flickers at the edge of a reality that prefers privacy. You exhale and let go of the need to use anything here. It's enough to know the cosmos carries a nervous heartbeat beneath the smooth orchestration of stars, like a symphony hiding a hummingbird's tremolo beneath the cellos. Historians still argue whether Wheeler truly coined black hole in 1967 or merely popularized a phrase that had already appeared in print. Fitting, since credit jitters in history the way energy jitters in the foam. And physicists still argue whether ER really equals EPR or whether that elegant slogan hides more questions than it answers. You let the debates drift by like distant traffic, present, persistent, and somehow soothing. Third joke. If arguments produced negative energy, we'd have stable wormholes by Thursday and a long weekend on Proxima. So you pocket 3 anchors for the road ahead. The obvious truth. The vacuum isn't empty, and the Planck scale lies beyond any microscope we can build without collapsing the stage. The quirky tidbit. It from bit, baby universes, and entanglement as geometry invite you to imagine information as the stitching of space itself. And the scholarly debate. Historians still wrangle over Wheeler's coinage, while theorists spar over ER equals EPR holography, and whether the foam is froth, lattice, or something we don't yet have the courage or vocabulary to describe. You let the ocean image return, moonlight on ripples, little hollows appearing and vanishing where silver meets shadow. The froth murmurs, quick and shy. Your fan keeps its faithful hum. And above the foam, the large-scale universe rolls on, serenely unaware of the tiny dramas below, like a ship gliding over waves too small for sailors to notice. You float with it, eyelids heavy, knowing that somewhere under the keel space-time is whispering, stitching, and unstitching, busy with secrets you don't have to solve tonight to feel their gentle pull. You rise from the froth of quantum foam, brushing off the fizzing static of Planck-scale tunnels, and you climb back into a cosmos still vast and dimly lit. Your gaze stretches toward the early universe, a newborn thing only moments old, glowing hotter than a billion suns crammed together. Out of that furnace, theorists suggest, came relics stranger than stars, cosmic strings. Imagine them as infinitely long, impossibly thin filaments of energy, left over from the great symmetry-breaking events in the first fractions of a second. An obvious truth. If the early universe had phase transitions like water freezing or steam condensing, then cracks in the cosmic crystal might have formed, and strings are one possible fossil of that change. You walk beside one now in your imagination. It's no thicker than a proton, yet denser than mountains, dragging gravity in a razor-sharp line across spacetime. If 2 such strings pass by each other, their immense tension could snap the geometry like twine under string. And here's the quirky tidbit. Theorists once joked that a single cosmic string looped through the Earth could squeeze our planet into a black hole. Not the friendliest neighborhood decoration, but the charm for dreamers like you lies in what strings might do to distances. 2 parallel cosmic strings could bend space so tightly that a shortcut between far-flung points emerges. Their gravity warps the canvas in narrow corridors, offering not a full wormhole tunnel but a stitched seam in the cosmic fabric. You picture galaxies sliding closer together as if pulled by an invisible zipper. You imagine civilizations marking the locations of strings like old-time mariners charting trade winds. Physicists still argue about whether these relics exist at all. Some models of the Big Bang predict them, others erase them. Astronomers scan the sky for their signatures. Double images of distant quasars, sudden bursts of gravitational waves from string loops snapping, but nothing decisive has appeared. The debate lingers, unresolved, like the faint afterglow of the cosmic microwave background itself. You smirk, because cosmic strings sound like something a novelist would scribble in the margins of a draft. Insert universe-sized violin string here. And yet they sit in equations with the same seriousness as stars or galaxies. Reality has a habit of elevating doodles into discoveries. So you imagine the sensory feel of one. You're floating near a cosmic string, though near is a generous word. Get too close, and you'd be shredded. The void hums with its tension, silent yet terrifying, like standing beside a cable stretched to breaking. The stars beyond look displaced, their light bent into arcs around the invisible filament. You reach out, but of course you can't touch it. It's thinner than thin, sharper than imagination, yet massive enough to reroute the universe's geometry. And here you rest on three anchors once again. The obvious truth: if the early universe had cracks, strings could be their fossils. The quirky tidbit: one loop through Earth could crush our planet into a black hole, which makes you grateful our yard is string-free. The scholarly debate: whether strings exist at all, and whether their gravitational pull could act as cosmic shortcuts, half wormholes in linear disguise. You lean back, fan humming, letting the image settle. Two cosmic strings, parallel and infinite, stretching into darkness, bending space-time like railroad tracks toward destinations unseen. You follow them with your eyes, but the lines vanish into night, daring you to imagine what they might connect, if anything at all. You leave behind the taut hum of cosmic strings and let your mind wander toward an even more mischievous consequence of wormholes: the possibility of bending not just space but time. You've been strolling through tunnels that promise shortcuts between galaxies, but what if they also let you sidestep clocks, cheat calendars, and peer over your own shoulder in history? An obvious truth: relativity already ties space and time together, so folding one means you're folding the other. A wormhole isn't just a cosmic alleyway, it's a potential time machine. The scenario plays out like this. Suppose you have a wormhole stabilized by your exotic matter barrels, still glowing softly in some corner of your imagination. If you take one mouth of the wormhole on a high-speed trip close to the speed of light and then bring it back, relativity ensures that less time passes for the traveling mouth than for the one that stayed behind. It's the twin paradox, but with a tunnel attached. Step through afterward, and you might emerge not just in another place, but another when, perhaps yesterday, perhaps centuries ago. Here's the quirky tidbit. In 1988, physicists Kip Thorne and Mike Morris actually crunched the equations and concluded that yes, relativity permits such a stunt in principle. They even published it, inviting anyone with enough exotic matter and engineering skills to give it a try. Imagine that, academic journals casually offering recipes for building a time machine, though with the caveat that it's wildly impractical and probably suicidal. Still, the footnote of possibility lingers like a mischievous wink from the cosmos. But of course, the headaches pile up quickly. Travel back in time, and you risk paradox. You might accidentally stop your grandparents from meeting, leaving yourself unborn, but still standing there scratching your head. Or you could hand your younger self the answers to tomorrow's exam, rewriting your own timeline until reality itself sighs in confusion. Scholars still debate whether these paradoxes are genuine contradictions or whether the universe has built-in self-consistency, laws that prevent them. Some argue time would loop smoothly, events locked into consistency no matter how you meddle. Others suggest reality would branch, creating parallel universes, each with its own history. You picture yourself walking into a wormhole with today's coffee still steaming in your hand, only to step out and find your yesterday self sitting there, scrolling on their phone. Do you wave? Do you hand over the coffee? Do you scold yourself for still not cleaning the kitchen? The situation is equal parts thrilling and absurd. The sensory imagery thickens. The wormhole throat glows faintly, and the walls seem to hum with the weight of conflicting timelines. You take a step, and suddenly the hum becomes the tick of 1,000 clocks, some running forward, others backward. Your skin tingles as if each hair is caught in a different direction of time's flow. The air smells sharp, metallic, like ozone before a lightning strike. The tunnel promises not just distance, but déjà vu. And here you rest again with your three anchors. The obvious truth: wormholes, in principle, could link not just places but different times, thanks to relativity's quirks. The quirky tidbit: respected physicists have actually published equations showing it could work, though they're quick to note that practical engineering is another matter. The scholarly debate: whether paradoxes doom the idea or whether the universe has subtle safeguards to keep causality intact. You smirk in the dim glow of your room. Time machines may sound like the stuff of comic books and B-movies, but here they are, emerging from the same sober math that explains gravity. You probably won't survive the trip, true, but you'll always survive the dream. You step carefully out of that shimmering tunnel of paradoxes, but the echo of ticking clocks follows you. Your mind can't help circling back to the unsettling thought: if wormholes can really bend time, what happens to cause and effect? Do we live in a neat line of dominoes, Or is the universe secretly a tangled web where some dominoes fall before they're even set up? An obvious truth: physics depends on causality, the principle that causes precede effects. Break that, and science itself stumbles. And yet wormholes poke at the seams of that principle. Imagine creating a loop in space-time where you can shake your own hand from yesterday. Do events still march forward? Or does the universe tie itself in knots? The very act of asking makes your temples throb, though maybe that's just the late-night fan hum making your thoughts swim. Here's your quirky tidbit. Stephen Hawking proposed what he cheekily called the chronology protection conjecture. He suggested the universe has a built-in insurance policy against paradoxes, quantum effects that surge to infinity and destroy any wormhole the moment it could be used as a time machine. It's as if reality itself slams the door shut with a stern, "No cheating." Hawking even joked that this conjecture might explain why we haven't been overrun by tourists from the future. If wormholes allowed time travel, surely someone would have popped in already to sell us futuristic coffee machines or spoil the ending of your favorite show. But scholars still argue whether Hawking's protection really exists or whether it's just wishful thinking. Some physicists suggest quantum fields might indeed destabilize time loops, blasting them apart with runaway radiation. Others insist we can't yet know, since we don't even have a complete theory of quantum gravity to settle the fight. The debate rages like a quiet storm, papers stacked like sandbags against the flood of paradoxes. You imagine standing in such a disputed wormhole. The air feels charged, the tunnel shimmering as if it resents being asked to host your temporal shenanigans. One side of the mouth whispers, "Forward," the other, "Backward," and you're caught in the tension like a rope pulled in both directions. Your stomach turns with the unease of knowing you might be both late and early for the same appointment. The sensory details wrap around you. You hear faint echoes, voices repeating, slightly out of sync, like overlapping tracks on a vinyl record. The stars beyond the throat blur into loops, some running clockwise, others counter. The tunnel smells faintly of ozone and dust, like an attic full of clocks left to tick in strange rhythms. You take a step, and your shadow splits, one striding ahead, one lagging behind, neither agreeing who you really are. It's dizzying, and it makes you smirk in the way only late-night speculation can. Maybe the universe really does police itself, stamping "invalid" on paradoxes before they can mess up the cosmic filing system. Or maybe it doesn't, and reality is just braver than you, able to juggle contradictions while you can barely handle your email inbox. So here you rest, once again with your anchors. The obvious truth: causality underpins science, causes precede effects, and wormholes threaten to scramble that. The quirky tidbit: Hawking's chronology protection conjecture suggests the universe actively prevents paradoxes, which is a very tidy way of keeping tourists from the year 5000 out of your living room. And the scholarly debate: whether wormholes really can create time loops, or whether quantum mechanics always slams the door before things get too messy. You lean back, eyelids heavy, and let the echo of those overlapping voices fade. The fan hum grounds you, reminding you that for now, at least, time in your room still marches forward, second by second, as steady as a heartbeat. But out there, in the shadow of wormholes, the question lingers: does the universe allow cheats? Or does it guard its timeline like a dragon on a hoard? You drift further, letting the echoes of paradox fade, and your mind steadies on a quieter thought. If wormholes are real, could we actually see them? Not in equations or daydreams, but through telescopes, instruments, and the slow patience of astronomy. An obvious truth: astronomers have gotten frighteningly good at detecting the unseen. We've never looked directly at a black hole, yet we've mapped their gravity through stars whipping around invisible centers. We've even photographed the shadow of one by pooling telescopes across Earth. So if wormholes lurked out there, surely we could sniff out their footprints. But what footprints would they leave? You imagine staring through a telescope at a distant galaxy, only to notice its light bending in a way that defies the neat arcs of gravitational lensing. A wormhole might mimic a black hole at first glance, warping light into rings and distortions. Yet some theorists argue the lensing would carry peculiar signatures, maybe double images, maybe flickers as the throat shifts, perhaps even ghostly duplicates of stars appearing where they shouldn't. You sit in the dark, picturing constellations stuttering, as if Orion can't decide which shoulder to raise. Here's your quirky tidbit. In 2009, a pair of researchers proposed that certain gamma-ray bursts, sudden flashes of high-energy light from deep space, could be wormholes hiccuping, opening and closing like cosmic throats that forgot their manners. It's speculative, bordering on playful, but you can't help grinning at the idea that what astronomers logged as mystery explosions might secretly be space-time clearing its throat. Of course, the scholarly debate here is far from resolved. Most astrophysicists are cautious, leaning towards simpler explanations. Black holes colliding, neutron stars merging, magnetic fields snapping. They point out that wormholes, if real, would need exotic matter scaffolding, and nature hasn't shown her hand on that yet. Others argue that just because it's exotic doesn't mean it's impossible. The universe has already surprised us with dark energy and quantum vacuum. Perhaps wormholes simply hide better than their rowdy black hole cousins. The sensory picture sharpens. You're in a dark observatory, the dome creaking as it rotates, the eyepiece cool against your brow. You peer through, and the sky wobbles, stars doubling, light rings shimmering faintly, a lensing pattern that feels slightly off. Your breath fogs the glass, and you half expect the tunnel to blink back, an eye behind the stars. The hum of machines blends with the night air, grounding you even as the idea unsettles you. You smirk at the thought of astronomers nervously writing papers that read like love letters to speculation. We cannot rule out a traversable wormhole as the cause. It sounds absurd, yet also delightfully human. Our instruments can map galaxies, but our imaginations still scribble at the margins. And so you anchor yourself once again. The obvious truth: astronomers rely on light, lensing, and radiation to detect the unseen, and wormholes might betray themselves through odd distortions. The quirky tidbit: some gamma-ray bursts have been playfully suggested as wormhole hiccups. The scholarly debate: whether any observed anomaly could ever be confidently pinned on a wormhole, or whether simpler, less exotic explanations will always win. You lean back, fan humming, and close your eyes. For a moment, you imagine the night sky above your home rippling, stars bending as though stitched to hidden tunnels. Maybe nothing's there. Maybe everything is. Either way, the sky feels alive with the possibility of doors. You recline deeper into the hush of your room, and the telescope's ghostly images give way to the softer glow of memory, because wormholes, whether real or not, have already traveled everywhere through imagination. If physicists argue about equations, storytellers have never hesitated to grab the idea and sprint. An obvious truth: wormholes are one of the most enduring tropes in science fiction, a ready-made narrative device to bridge impossible distances. When you want your characters to hop galaxies before breakfast, you don't need physics. You need a shimmering doorway. Think of it: Stargate, with its rippling blue portals; Star Trek, with stable wormholes providing shortcuts across quadrants; Interstellar, where Thorne's math gave Hollywood a throat rendered as a magnificent, glowing sphere of distorted stars. The imagery is irresistible. Instead of slow rockets and weary astronauts, wormholes promise drama, mystery, and speed. You probably remember at least one movie where a character steps into a swirling tunnel and emerges somewhere new without so much as jet lag. Here's your quirky tidbit: C.S. Lewis beat many sci-fi writers to the punch. In his 1938 novel Out of the Silent Planet, he described interplanetary travel through what we'd now recognize as a wormhole-like shortcut, long before wormhole was a household word. Even fantasy authors flirted with the idea through magical portals, wardrobes, rabbit holes, enchanted doors, because at heart, wormholes are just the scientific veneer over a universal human dream. Leaving here, arriving there, skipping the boring in-between. Yet scholars still debate the cultural weight of this borrowing. Some argue that science fiction confuses the public, making people think wormholes are as real as Mars rovers. Others counter that without fiction, nobody would care enough to fund the telescopes and equations. Imagination, they argue, is the first step toward discovery. Historians of science still argue whether Einstein himself would have rolled his eyes at Stargate or quietly smirked at its boldness. You let the sensory details thicken. Picture yourself sitting in a worn cinema seat, popcorn balanced in your lap, as the screen erupts with a glowing circle of light. The bass rumbles in your chest, the audience leans forward, and you feel the tug of anticipation. The portal opens, someone steps through, and the crowd gasps. In that moment, the fiction doesn't matter. You felt, viscerally, the thrill of what it might be like. That thrill lingers long after the credits roll, humming in your imagination like the fan hum in your room. And here you return to your anchors. The obvious truth. Wormholes are a staple of storytelling, beloved because they solve the problem of distance with elegance. The quirky tidbit. Even before physics gave them a name, literature was already inventing them under other disguises. The scholarly debate, whether fiction helps or harms scientific understanding, inspiring some while misleading others. You smirk softly in the half-dark. Whether real or imaginary, wormholes have already tunneled through your bookshelves, your screens, and your dreams. They may not exist in the cosmos, but they definitely exist in culture, and for tonight, that might be just as powerful. You let the cinema glow fade and drift back into your own thoughts, where the line between equations and entertainment feels blurrier than ever. If wormholes dazzle in fiction, what happens when you set them beside the hard chalkboards of science? You can't help but chuckle at the gulf between pop science imagery and the stubbornness of real math. An obvious truth. Most depictions of wormholes in movies are wildly inaccurate, but they work because they stir your imagination. Think of those swirling whirlpools of light, perfect circles shimmering with sound effects that echo like thunder in a cave. They make great posters, but the equations don't actually predict neon-colored funnels you could fly through like a water slide. In reality, a wormhole mouth, if one existed, might just look like a dark sphere distorting starlight, indistinguishable from a black hole unless you knew its secret. That's less cinematic, but more faithful to relativity. Here's your quirky tidbit. When Interstellar needed its wormhole visual, Kip Thorne and the effects team at Double Negative built an actual simulation based on Einstein's equations. The rendering was so precise that Thorne later published a scientific paper on the images themselves. Imagine that. Hollywood accidentally pushing physics forward just by insisting on cooler special effects. You smirk at the thought that the most accurate wormhole model to date began with a studio executive demanding something that looked pretty on IMAX. Yet the scholarly debate rumbles on. Some physicists complain that pop science overhypes wormholes, making the public think they're just around the corner. Others counter that hype fuels curiosity, which fuels funding, which fuels discovery. Without a little cultural glitter, would anyone care enough to chase negative energy or quantum foam? Historians still argue whether science communication should lean on wild visuals or stay austere, letting the equations speak for themselves. The sensory details gather again. Picture yourself at a science museum, where a glossy exhibit shows a glowing wormhole toy model. Kids press their noses to the glass. Parents nod, pretending to understand. Beside it stands a physicist, holding a marker and a tired smile, scribbling equations that no one is reading. The tunnel glows neon, the chalk squeaks dry, and you feel the tug of two worlds colliding, fiction that thrills and math that resists. And here, as always, you gather your anchors. The obvious truth. Cinematic wormholes rarely match the physics, though the imagery works. The quirky tidbit. Hollywood once produced visuals accurate enough to merit a peer-reviewed paper. The scholarly debate. Whether pop science illusions mislead or motivate, whether we'd lose curiosity without the glitter. You lean back, eyelids heavy, and smirk again. Wormholes may or may not exist, but one thing's certain. The distance between math and movies can itself feel like a tunnel, sometimes short and inspiring, sometimes impossibly long. Tonight, at least, you've wandered both ends. You let the clash of chalk and cinema fade, and now your mind drifts into more dangerous territory. What if civilizations actually tried to build a wormhole? Not stumble across one, not spot it with telescopes, but engineer it on purpose. The thought itself feels reckless, like giving a toddler a flamethrower. Still, you can't resist. An obvious truth. Any attempt to construct a wormhole would require technology far beyond anything we have now. Yet the temptation lingers, because humans can't resist building bridges once they imagine them. You imagine the blueprint. First, find a black hole, or make one. Don't worry, you'll need one that's tiny, stable, and ideally non-devouring. Then gather the exotic matter, those glowing barrels from earlier, each pulsing with negative energy. Position them like scaffolding along the throat, reinforcing the geometry, keeping the tunnel propped open. Add stabilizers, maybe giant electromagnetic fields, maybe quantum devices the size of planets, to hold everything steady. Finally, you align the mouths, one near your home world, another dragged across the cosmos by some unfathomable tugboat drive. Voila! A wormhole toll booth. Here's your quirky tidbit. Theoretical physicist Matt Visser once worked out equations showing how a traversable wormhole might be maintained, complete with stress-energy tensors mapping the exotic matter distribution. He essentially handed the universe a DIY manual for cosmic shortcuts, though the fine print basically reads, "Warning, requires materials that don't exist." You grin at the absurdity, a cosmic IKEA guide, complete with missing screws. The scholarly debate, of course, is whether any civilization could ever muster the resources. Some argue that advanced species might wield technologies we can't even name, harvesting vacuum energy, sculpting spacetime like clay. Others counter that the energy requirements scale so wildly that wormhole engineering remains indistinguishable from fantasy. Historians still argue whether we should even talk about this seriously, or if it's just physics moonlighting as science fiction. The sensory imagery thickens. Picture yourself in the control room of such a project. The walls thrum with energy, glowing conduits feeding into the trembling throat of a newborn wormhole. Technicians, alien or human, take your pick. Monitor shimmering screens that display distorted grids of spacetime. The air tastes metallic, buzzing on your tongue. Through the tunnel, you glimpse another star system, blue-white light flickering like a candle. And in the back of your mind, you wonder, what if it collapses mid-step? What if the exit veers somewhere else, into a star or into nothing? And here you settle with your three anchors again. The obvious truth: building a wormhole would require physics and energy far beyond our reach. The quirky tidbit: physicists like Visser have actually drawn up serious papers sketching the how, even if the answer is good luck. The scholarly debate: whether civilizations could ever do this in practice, or whether the equations are just thought experiments dressed as engineering. You smirk in the dim hum of your room. Humans already fling rockets toward the edge of the solar system, build colliders to smash particles, and send robots to icy moons. Dreaming of wormhole construction may sound ridiculous, but so did flight once, and electricity, and the idea that you could listen to a story from me in the dead of night. Maybe one day, some civilization does hammer spacetime into bridges. Until then, you let the fantasy carry you. You linger in that control room of humming conduits and shimmering throats, and your imagination stretches further still. What if wormholes weren't just experiments in dusty laboratories of advanced civilizations, but actual highways of interstellar travel? An obvious truth: rockets, even our fastest, crawl at a snail's pace compared to the distances between stars. Voyager 1, humanity's farthest probe, has taken nearly 50 years to skim into interstellar space, and it's still barely a toe outside the solar system. At that speed, reaching even the nearest star would take tens of thousands of years. If you want a road trip to another galaxy before your snacks expire, rockets are hopeless. So you picture a future where wormholes replace propulsion entirely. No more acceleration, no fuel tanks the size of skyscrapers. Instead, civilizations chart wormhole networks like highways, mapping safe exits, trading routes, and scenic shortcuts. Spaceports aren't launch pads, but wormhole hubs. Massive stations orbiting wormhole mouths, lit up with traffic lights, toll booths, and, because you're feeling cheeky, the occasional cosmic rest stop. With vending machines. Here's your quirky tidbit: the idea of using wormholes as transportation isn't confined to fiction. Nobel laureate Frank Wilczek once mused that if stable wormholes existed, they could, in principle, be cultivated into networks, cosmic subways connecting star systems. His point wasn't that we can build them now, but that nothing in the equations outright forbids such possibilities. You imagine Wilczek scribbling that thought with the same half-smirk you wear when sneaking an extra cookie at midnight. The scholarly debate, naturally, centers on feasibility. Could wormholes ever be stable enough, large enough, and safe enough for actual travel? Critics argue the energy costs are astronomical, the risks lethal, and the engineering incomprehensible. Supporters argue that calling something impossible has a poor track record in science. Historians of technology still argue whether railroads or airplanes were once considered equally absurd dreams. Wormholes, in that light, are just the next step in humanity's love affair with shortcuts. The sensory imagery unfolds in detail. You step onto a colossal orbital station hovering beside a wormhole mouth. The structure glows with docking lights, and ships of every size slide toward the shimmering sphere that distorts the stars. Through the viewport, you watch one vessel tilt forward, its nose touching the edge of the tunnel. In an instant, it's gone, swallowed into geometry, reappearing light years away before you can count to 3. The hum of engines is replaced by the hush of inevitability. Travel has changed forever. You smirk at the thought of interstellar traffic jams, queues of ships lined up at wormhole gates, captains tapping their controls impatiently while cosmic road work ahead signs flash. Maybe even toll fees, because some truths, taxes, delays, complaints, persist no matter the century. And so your anchors settle once more. The obvious truth: rockets are too slow. Wormholes, if possible, could revolutionize interstellar travel. The quirky tidbit: even serious physicists have speculated about wormhole networks as future highways. The scholarly debate: whether stable, traversable wormholes are anything more than mathematical curiosities, or whether they might someday become the infrastructure of a galactic civilization. You lean back into your pillow, fan humming steadily, and let the image linger. Ships vanishing into spheres of warped starlight, exits blooming across galaxies like fireflies in the dark. Travel redefined, distance undone, the universe stitched together by glowing corridors that hum with the footsteps of explorers. You hover at that glowing hub of interstellar travel, ships slipping effortlessly through wormhole mouths like commuters on a morning subway line. But of course, your imagination can't stay polite forever. It begins tugging at the shadows. What are the risks of this ride? Because if there's one obvious truth, it's that shortcuts rarely come without potholes. Wormholes may glitter like cosmic expressways, but the hazards are enough to make even the bravest pilot sweat. First, the tides. Not the gentle rise and fall of oceans, but tidal forces so extreme they could stretch you like spaghetti. Spaghettification, the charming technical term. Imagine stepping through a wormhole throat where gravity pulls harder on your feet than your head, elongating you until you resemble cosmic linguini. Not exactly the glamorous interstellar selfie you had in mind. Then, the radiation. Wormhole mouths near black holes or neutron stars would bask in lethal baths of high-energy particles. Step in unprotected, and you'd be cooked faster than popcorn in a microwave. You chuckle grimly. Suddenly, that interstellar road trip looks less like a family vacation and more like walking into a tanning booth dialed up to 11. Here's your quirky tidbit. In the 1990s, some theorists speculated that wormholes might not just collapse, but explode when disturbed. If exotic matter fields weren't perfectly balanced, the tunnel could release catastrophic amounts of energy, vaporizing anything nearby. You picture a ship entering the throat, and instead of a quiet whoosh, the whole thing goes off like cosmic dynamite. Wormholes, both the ride and the fireworks. And scholars still argue whether any of these dangers can be mitigated. Could shielding protect against tidal forces? Could advanced civilizations balance the exotic matter scaffolding precisely enough to avoid explosions? Or are wormholes simply nature's cruel joke, mathematically possible but physically suicidal? The debates pile up, papers citing each other in circles, each one essentially saying, "We don't know, but here's my guess." The sensory imagery grows sharper. Picture yourself inside a wormhole corridor. The walls ripple with distorted starlight, every photon bent into ribbons. You feel a tug on your body, subtle at first, then stronger, pulling you into elongated shapes. Your chest tightens as radiation prickles against your skin, invisible sparks gnawing at your cells. The silence is immense, yet you sense danger humming in every curve of the tunnel. The exit ahead flickers unpredictably. Sometimes it shows a starfield, sometimes nothing at all, a void of black. One wrong step, and the whole tunnel could collapse, leaving you stranded or shredded. And here come your anchors, steady in the swirl. The obvious truth. Wormholes are as dangerous as they are alluring, with tidal forces and radiation ready to shred careless travelers. The quirky tidbit. Some models predict wormholes could outright explode if disturbed. And the scholarly debate, whether advanced civilizations might someday tame these hazards, or whether wormholes are forever forbidden fruit. You smirk in the dimness, because of course your imagination went here. Every shortcut comes with warning labels, and wormholes are covered in them. May cause collapse, spaghettification, or spontaneous annihilation. Still, you let the image of that trembling tunnel linger, dangerous but irresistible, like a thrill ride you know you shouldn't board but can't stop staring at. You hover at the edge of that dangerous tunnel, feeling the last tremors fade, and what refuses to fade with them is your curiosity. It doesn't care about radiation warnings or spaghettification signs. It keeps tapping your shoulder like a polite, relentless roommate. Why do you still believe, if not in wormholes themselves, then in the value of chasing them? Because even a mirage can teach you something about the desert. You let the fan lay its soft ribbon of sound across the room and realize the chase is the point. The steady, sleepy practice of turning questions over until they shine. Start with the big, stubborn thing, ignorance. You don't know what quantum gravity looks like yet. Nobody does. Einstein's canvas curves beautifully, but it frays at the Planck scale. Quantum fields sing, but they crack when the notes get too heavy. Between them is a gap, and gaps are invitations. When you imagine wormholes, you're running your fingers along the seam, testing the stitching, listening for hollow spots that might ring with new physics. An obvious truth. Progress often begins at the edge of what we don't know, not at the center of what we do. Then there's precedent. Gravitational waves spent a century as rumor before they chirped in our detectors. Black holes were once dismissed and now pose for portraits as orange rings. That doesn't mean wormholes must follow. It just means the universe sometimes cashes checks written by daring math. You smirk at your pretend grocery list. 1 metric ton of negative energy. Because even jokes have jobs. They let you cradle an impossible idea long enough to notice its seams. A joke loosens the lid so a question can breathe. Hope isn't the only fuel. Discipline is, too. You picture researchers running simulations that aren't glamorous enough for IMAX. No glowing spheres, just grids and boundary conditions, parameter sweeps that make coffee go cold. They publish no after no and call it mapping. Every no tightens the perimeter of maybe until what remains is manageable, testable, real. It isn't romance. It's cartography with a pencil you have to sharpen every few pages. You exhale and feel the shavings gather in your lap. Proof that practice is a kind of progress. Here's your quirky tidbit. A few fringe proposals suggest civilizations might seed tiny, non-traversable wormholes as standards, not for smuggling starships, but for calibrating clocks and gravity between distant stations. Think of them less as doors and more as cosmic yardsticks, epoxied into foundations to measure a structure as it sways. You can almost see a galactic engineer tapping a wormhole stud with a clipboard, muttering, "Yep, still plumb." Practical? Not with the toolbox you own, but imagination sketches blueprints long before the crane arrives. Belief also leans on humility. Nature doesn't owe you convenience. The cosmos is under no obligation to supply highways just because your snacks have expiration dates. But humility has a twin called audacity, the decision to ask anyway. When you fold paper to bring two dots together, you aren't promising the universe anything. You're promising yourself that you'll keep looking for kinder geometries. Maybe the paper refuses to fold. Maybe it creases a little. Maybe it tears and teaches you how strong it is. Either way, you learn something you didn't know before the crease. And there's the civic side of curiosity, the way a culture of wonder builds tools that outlast the questions that birthed them. Maybe nobody ever stabilizes a wormhole throat with negative energy barrels. Sorry, warehouse manager. But chasing that fantasy can gift better detectors, smarter algorithms, sturdier magnets, and new math that turns up somewhere embarrassingly practical, like making GPS less grumpy or coaxing your Wi-Fi not to die the instant the kettle boils. Grant committees don't fund daydreams. They fund instruments. But instruments are what daydreams become when they grow up. Memory joins the conspiracy. You carry the hush of an observatory dome rotating under starlight, the IMAX glow of a simulated throat, the first time someone folded a napkin and said, "See? That's a shortcut." Those moments live rent-free in your head, and they vote in the council of what you care about next. Historians still argue whether the late 20th century wormhole craze in pop culture nudged funding priorities or whether money followed more bureaucratic currents. You suspect both can be true, the way tides and winds both move a ship. Doubt sits at the table, and you keep it fed and watered like a houseplant because it keeps the room breathable. Doubt asks, if wormholes demand exotic matter we've never seen at macroscopic scales, shouldn't you pour your energy elsewhere? Doubt wonders whether ER equals EPR is poetry getting ahead of itself. Doubt taps every pretty visualization and listens for hollowness. You're grateful for the tapping. Without it, you try to move in before the paint dries. Joke 1. You once tried that with a new apartment and still have constellation-shaped speckles on your jacket. Faith, small f, scientific kind, makes its quiet case. You don't need certainties to keep going. You need methods. Measure, model, argue, repeat. You believe in the part where reality surprises you just often enough to justify the coffee. You believe in the vanishingly thin possibility that somewhere, somewhen, a telescope catches a lensing pattern that won't fit the usual suspects, and the data refuses to sit down until someone whispers, "tunnel," and doesn't get laughed out of the room. You believe that if the answer is no, the honest work of reaching it still leaves maps behind for the next traveler. Then there are the smaller, sillier reasons, the ones that matter because you're human. You like folding paper and drawing dots. You like the way your fan harmonizes with the math, a white noise backing track for the mind's small rebellions. You like telling yourself that if arguments really produced negative energy, we'd have a network by Thursday and a long weekend on Proxima. Joke 2. The galactic HOA would still reject your backyard portal because the hedges aren't symmetrical. Affection isn't a proof, but it's a fine reason to keep reading past midnight. Curiosity also respects risk. You're not pretending the ride is safe. You remember the tides, the radiation, the collapses, and the hisses. You picture checklists as long as launch towers, ships sheathed in shielding, engineers arguing about tolerances you can't pronounce. You nod at their caution and think, good. Bravery without helmets is just a headline. When the dream is frank about its hazards, you trust it more, the way you trust a map that draws the cliffs with ink as dark as the sea. So you gather tonight's anchors. The obvious truth, pursuing hard, maybe impossible ideas is how science finds its edges, and wormholes are an edge worth mapping even if they never host a road trip. The quirky tidbit. Those speculative yardstick wormholes show up in papers as calibration fixtures, not stargates. Less dazzle, more level. And the scholarly debate that refuses to sleep. Physicists volley over quantum gravity and causality, while historians still argue whether culture led funding or funding led culture in the wormhole heyday. At last you let your shoulders drop. The room is dim and kind, the fan steady, the sky outside a library of old light. You don't need a guarantee to keep walking. You need that shoulder tap, the soft insistence that even mirages draw maps. You turn one last time to the folded paper on your desk and smooth it flat, then crease it again, gentler, surer, knowing the sheet will teach you something either way. And if the universe is giggling at your audacity, you giggle back. Joke 3. You promise to walk and feed your wormhole twice a day and clean up after it. You're still here, still looking, and the looking itself is the bridge. You linger on the rim of that imagined corridor, letting the station lights dim to fireflies and the starfield relax into a quiet wallpaper. The hum in your room keeps time with your breath, and the story you've been telling softens around the edges. You don't need a ship to step anywhere. You stay where you are, and still you travel. That's the quiet magic you've rehearsed all night. Curiosity as transportation. An obvious truth settles gently. Even if no traversable wormhole ever materializes, wonder doesn't wait for permission. It finds routes through attention, metaphor, and the slow practice of looking. You tilt your head, and distance bows politely. You breathe, and clocks seem to loosen their grip. You are not escaping the universe. You are easing closer to it. You let earlier images drift by like lanterns. There goes the paper folded so two dots touch, the napkin crease that made the galaxy feel neighborly. There goes the trembling cardboard tube, collapsing the moment you tried to push a marble through. There go the barrels of exotic matter, glowing in a warehouse that would terrify any safety inspector. You stack the labels neatly in your mind. Do not tip. Do not sneeze. Do not open during dinner. Joke 1. Somewhere there's a galactic OSHA brochure with a cartoon astronaut shaking a can of negative energy and the caption, "Don't." You smile anyway, because the props of the night, creases, tubes, barrels, have done their job. They turned abstractions into things your hands could almost hold. You think of the strings, taut as violin wires, of the foam that fizzes under Einstein's smooth canvas, of lensing patterns that might someday blink wrong and refuse to be ordinary. You think of time's looped corridors and of Hawking leaning in from the far side of a paradox to whisper, "Not today." You think of cinema's rippling circles and engineers' chalk-dry diagrams and how both are, in their own way, love letters to the same itch, to make far feel near, to make strange feel spoken. The room is quiet, and that quiet is crowded with good company, ideas that have learned to sit still long enough for you to listen. Your hands make a small tent with the bedsheet, and under it you hold the simplest instrument, attention. It points like a compass toward what matters. It tells you when an explanation sings and when it stalls, when a pretty rendering hides a brittle assumption, when a grim equation hides a door. You breathe, and the compass steadies. You notice the room again, the faint draft on your ankle, the distant car, the ordinary that now feels jeweled because you've been trained by starlight to look closely. You've been rehearsing a gentle skill set. Fold, compare, doubt, smile, continue. Quirky tidbit time, because the night still has pockets. Stephen Hawking once threw a party for time travelers and mailed the invitations afterward, just to see if anyone would show up. Nobody did, which either proves the universe protects its chronology or that future tourists have better taste in hors d'oeuvres. You picture him in a quiet room with chilled champagne and a clock set to impossible, waiting like a gentleman at a door that stays locked, and you feel the good-natured mischief of a scientist testing the limits with a wink. Historians still argue whether fiction pulled research money along in its wake or whether the funds were already flowing and the stories simply surfed them. They also still argue whether Einstein and Rosen were patching singularities or peeking toward passageways, and whether the word that stuck in your mind, wormhole, sprang from a single coinage or seeped in through many minds at once. The arguments matter because they encode our appetite for bridges. They are, in their fussy way, measurements of what we hope to build. You nod to them, grateful that even disagreements can be lanterns. So you practice a gentler daring. You imagine the network again, hubs and gates and the occasional cosmic rest stop with a vending machine that eats your credits anyway, because some injustices transcend galaxies. Joke 2. You shake the machine and a bag of exotic matter bites drops with a label that reads negative calories. You keep the joke because it keeps the dream from taking itself too seriously. Yet you feel the counterweight too, the risks you listed like storm warnings, tides that stretch, radiation that bites, corridors that shiver into nothing the instant you touch them. You don't look away from the hazard signs. You read them until the letters blur and become respect. You test a sentence in the dark. Curiosity is a bridge even when there's no road. It lands softly. If tomorrow's telescopes never catch an odd lens that whispers tunnel, if future engineers never find a stable throat to scaffold, the maps you made on route still matter. They rewire a small corner of how you hold the sky. They put handrails on the edges of confusion. They let a child fold a page and say, "What if?" without apologizing for the crease. If that child grows up and never meets a wormhole, the habit remains. The ease with which a question becomes a path becomes a practice. You think back to the first line you spoke tonight, the velvet dark and the thin hum. Not much has changed in your room. Outside, the neighborhood is the same soft geometry of sidewalks and hedges and distant traffic. No gate irises open beside your dresser. No star spills through your window. And yet there's a new steadiness in your neck and shoulders, as if someone adjusted the horizon line inside your head. Joke 3. You now consider your swivel chair a relativistic training device. One gentle spin, and you feel time dilation, or at least a strong opinion about snacks. You breathe, and the ordinary feels aligned. What remains are three anchors you can keep with the lights off. 1. Scale. Space is not just big, it's character building. Let the size teach you patience rather than despair. 2. Texture. The vacuum is not empty, the quiet has a grain. When you listen closely, even nothing has a story. 3. Argument. Good faith disagreement is a renewable resource. If it ever powers a negative energy generator, remember who told you to invest early. The anchors aren't proofs, but they are promises that your gaze can keep finding purchase where the world once seemed slick. You nestle deeper, inventorying your callbacks like keepsakes. The origami paper, the cardboard tube, the double images, the humming station, the traffic report at Wormhole Exit 7. The grocery list with Andromeda's ETA, the galactic HOA ticketing your uneven hedges, the calibration wormholes used as yardsticks and not as doors. Each is a bead on the same string. The habit of seeing around corners without pretending you've already turned them. The habit, in other words, of remaining honest while you're en route. A last uncertainty pads over and curls at your feet. Maybe ER never equals EPR in the way you hope. Maybe exotic matter remains a laboratory whisper, all Casimir and no cargo. Maybe the only bridges are metaphors, and the only tunnels are paragraphs. The thought doesn't bruise you the way it would have an hour ago. You've walked far enough tonight to recognize that the value wasn't in arriving. It was in the way you learned to walk, how you traded blankness for contour, noise for note, distance for depth. You didn't dodge the universe, you learned its handwriting. You glance, finally, toward the shade where your fan turns and let the rhythm choose your closing cadence. No declarations, no neon gates, just the steady awareness that wonder survives answers and sometimes grows because of them. You yawn, the galaxy obligingly redshifts, and the corridor you've been standing on all along reveals itself for what it is. Not an escape from the universe, but a way of staying with it, closer, quieter, and, somehow, more at home. Breathe in, slowly, as the edges of the room soften and the starlight you've been carrying fades to a friendly blur. Let your shoulders drift a little lower, and let your jaw unclench, as if the night were smoothing a crease from paper you've folded and unfolded with care. The fan offers its small, faithful weather, steady, patient, easy to trust, and you match that rhythm without trying. Each exhale lengthens, trailing a loose ribbon of warmth that settles across the chest and down the arms, through the hands, until even your fingertips are quiet. Let the corridors you imagined become lighter, more porous, as if the walls were only mist that remembers how to be air. Let the equations soften into shapes, the shapes into outlines, the outlines into nothing but a comfortable hush. If thoughts arrive, let them arrive the way distant headlights drift along a wall, gliding, harmless, already on their way to somewhere else. If a question insists on staying, promise it a small corner of morning and watch it nod, agreeable, and curl up to rest. Feel the ordinary world hold you. Mattress, blanket, pillow, the familiar arrangement that asks for nothing and offers enough. Outside, some small piece of the night keeps watch, leaves shifting, a quiet car, a dog that has decided not to bark. Inside, your breath makes its gentle bookkeeping, counting without numbers, measuring without effort. The distance you explored has come home to your pulse, unhurried and kind. Let your eyes grow heavy. Let your hands be still. Let the last of the starfield tuck itself behind your lids like a soft, dark ribbon. No doors to open, no gates to hold. Only the slow, certain easing of weight from bone and thought from thought, until the room is only breathing, and the breathing is only you, asleep.